In this section of our ongoing series of video lessons on creating a platformer, we are going to set things up so that our player is able to attack our enemies. When we last left off, we had our enemies animating and walking and colliding with walls, and we were able to create various versions of them, but we can't actually interact with them in any way yet. So let's get that working next. First of all, let's go back to our bullet. So right now, as you saw just a moment ago, when the player fires a weapon, the bullet just passes through the enemy, so we don't want that. So let's come into the bullet object and we'll add a collision event with the player, or sorry, with the enemy, I should say. And what do we want to do in this collision? Well, we want to reduce the hit points on the copy of the enemy that the bullet has collided with. So with other will allow us to speak directly to the specific copy of the enemy that we've just collided with, and we will subtract 1 hit point. HP minus equals 1. And because we're saying with other, we're talking to the hit point variable that we set up on our enemy by using variable definitions. See, hit points equal 4 is what we set it up to by default. So that'll reduce it down by 1. And while we're at it, still speaking to the copy of the enemy, we are going to update the hit from variable that we also set in those variable definitions when we set up our enemy object to other dot direction. Now, what are we going to use this for? I mentioned briefly in the previous lesson, but this hit from variable, instance variable, it's going to live on each of our enemy object instances, is going to store the angle from which the bullet hits the enemy. So by saying hit from equals other, now we're changing the sort of reference back here to our bullet again, and whatever direction it's moving, that's what we'll put inside here. So for example, if the enemy bullet hits, or excuse me, if the player's bullet hits the enemy from the left side, that means it's moving to the right, which means its direction is 0, and so hit from would be 0, where if the bullet is coming from the right hand side and moving toward the left, then the hit from direction will be 180. All right. Coming back out, now talking to the bullet itself, not to the instance of the enemy, we want to destroy the bullet. There we go. All right. So effectively all we're doing here is destroying the bullet, reducing the hit points on this copy of the enemy, and then storing which direction the bullet came from. So far, so good. But what happens if the hit points on our enemy reaches 0? Well, right now nothing happens, so we need to set that up. And we're going to set it up in a kind of, well, it's not a unique way. It's a variation on something we did back in the koala game. In the koala game, if our koalas ran into one of the hazards, like the rotating saws or the TNT, you may remember that what we did in that collision was to switch from the regular koala object to a dead koala object. And that dead koala object performed some actions to make it drop down out of the room. So we're going to follow a version of that here. So we need to create a new object. This will be, let's call it O dead. This will be our dead enemy. For the sprite, you can see we've got our dead sprite, or I should say our dead enemy sprite. And on our enemy object, let's add a create event, just like we did back with the koala. And we're going to do a whole bunch of stuff here on this dead enemy sprite. Now on our regular enemy object, we set up a collection of variables, and I showed you that sort of new cool way of defining variables in variable definitions. Well, we're going back and not using that this time, instead using a create event to define and initialize some variables here. So we're going to give our dead enemy object its own horizontal speed, its own vertical speed. Notice that the vertical speed is -4, so it's going up. Its own gravity. We'll say, let's say 0.34. And then we're going to have something called done, which we'll get into in a moment, but we'll say 0 or false. It's not done yet. When we create the enemy object, we want to give our player some points. So we haven't set this up yet. So I'm going to come, let's see. Well, I'm going to leave that alone. We'll come back in a minute. I'll put a little note here. Define and update score. Okay, so we'll come back and do that in a little bit. In addition, here on the enemy object, we want to set the image speed equals to 0. And the reason we're doing that is because our enemy object sprite has 2 frames in it. Just like our bullet did, right? And other objects we've used up to this point that have 2 frames that we don't want to animate. We need to tell GameMaker, hey, don't animate the sprite that goes with this dead player object. All right. Oh, we're gonna do a whole bunch more stuff. I'm trying to think if I want to start doing it all now. Now I'll come back to a couple of the more fancier things I want to do with this dead enemy object a little later. For now, we've got our instance variable set up. We're making sure that the image doesn't animate. I also want our enemy to disappear after a certain amount of time. Now, one approach which we've used before, especially when we have objects that have sprites with lots of sub-images that animate, is to use animate n, but that doesn't really work here because we're not animating, first of all, and we only have 2 sub-images, so we would only have the object appear on screen for a brief time. So in this case, if we want the object to appear on screen for a little while, then we want it to disappear, a real easy way to do that is to set an alarm. I'll make a note, make the enemy disappear after some time. All right. So let's set an alarm. And remember, there are different ways to do this. Here I'm using the alarm set function. I'm going to do alarm 0. And I'm going to set the length of time equal to the room speed times 5, which is a way of making sure that your alarm is set for 5 seconds. Okay. Well, since I've got that set up, we'd better go now back into our event and set up an alarm event. And what do we want to have happen when that alarm goes off? Well, we want to destroy the instance of the enemy. All right. But that's not all. So our dead enemy object, the way it's going to work is that imagine the player is firing his weapon at the enemy, dropping hit points with each shot. Hit points eventually reach 0. When they reach 0, we're going to then instantiate a copy of the dead enemy object out onto the screen and give it all of this information. But why are we giving it horizontal, vertical speed, gravity, and all of that stuff? Well, the reason we're doing that is that we want to allow the dead enemy, just like the living enemy, to be able to fall, basically. So imagine that you hit your enemy and hit point reaches 0, and then you create a copy of the dead enemy object. We want that dead enemy object, sort of like the koala, to move. And if we're going to have the dead enemy object move, we want it to react to walls so that it doesn't go through a wall. We want it to react to floors so it doesn't go through floors. essentially like our player and like our other regular old enemy object. And to make all of that happen, then we can sort of borrow the same bits of code that we have used for everything else and you know, all of our other collisions and movements. So I'm going to add in a step event here. And I'm going to, because I'm a little lazy, I'm going to just paste in all the code that we used for our enemy object with one change, okay? So what we've got here, again, just to make this clear, what I've just pasted in here is the exact same collision detection code that we have in the step event for our other enemy object. We're applying gravity, we're checking for horizontal collisions, and we're checking for vertical collisions. So it's all the same stuff as that collision piece, okay? Not the animation stuff, just the collision part. But here there is one big change. So from here to here is all, you can just copy and paste all the code that you put into the regular enemy object for its movement and collisions. And then I wrapped all of that code inside an if statement that checks if the value of done is equal to 0. And remember that we set up on our create event for our enemy this value of done. Okay? How are we using that information? Well, we want the enemy object, the dead enemy object, when it is created to sort of fly up into the air left or right, looking like it's been hit by the bullet. And then we want it to land back onto the platform. And when it lands back on the platform, we need to have the dead enemy object not move anymore. If we didn't wrap this whole thing in this check to see if done value is equal to 0, and then when the dead enemy object lands on a platform to update that done variable to 1 or true, what would happen is that our player, our dead enemy object, would fly up in the air, it would land down on the platform, and then it would keep moving until it ran into a wall. So let me demonstrate this. So with this code all wrapped up in this check, the only other change is that inside the vertical collision, we are placing this change that says done equals 1 right here. Okay, so I'm going to comment that out for a second. Well, I can't show you yet. I've got to set up the ability of our dead enemy object to be created. So I'll come back. So just trust me for now. We'll come back and take a look at this. So this will make it so that once the dead enemy object lands on a platform, it doesn't keep sliding along the floor. It will be easier to show you once we get it set up. Okay. So this is showing the entire script for the step event for our dead enemy. So you can pause the video and go in and get all this and type it out, or if you want to save even more time, just go back to your regular dead enemy object and copy and paste it all in, but wrap it in this if statement and then add done equals 1 inside the vertical collision right here. Okay? Okay. Now then, we need to make our game able to create a dead enemy object. So where can we pull that off? Well, if you think about it, each one of the regular enemy objects has its own copy of hit points, right? HP. And each time each copy of the enemy object is hit by a bullet, we're decreasing hit points by 1. And so if we want to set up the ability to create a dead enemy object when the regular enemy object's hit point reaches 0, it makes sense to do it here on the enemy object. And in fact, we could do it here inside the step event. That's how we've been running things previously on other assignments. We could create a new region in here to organize things and then check to see if hit points have reached 0. And that would actually work. But we can get a slightly different visual effect by using, instead of the regular step event, use the begin step event. And since I'm following a heavily modified version of Sean Spaulding's platformer, that's what he does. So in case you want to get in and follow his lessons for a different take on this, let me follow roughly what he does. So we're putting it in the begin step event. And what is it we want to do? Well, we need to check if the hit points for our enemy have reached 0. So if HP is less than or equal to 0, then we want to do a whole bunch of stuff. And what's the main thing we want to do is that we want to create an instance of the dead enemy object. So we'll do a similar approach to what we've done earlier in this same project when we were creating our bullet instances. We're going to say with, so that we'll be able to talk to a specific copy of the dead enemy object, and we will then create a copy of the dead enemy object, instance create layer. We'll position it just right where the regular enemy object is, so X and Y. For the layer, we'll put it on to enemy. And which object do we want to create? We want to create a dead enemy object. Okay. Because we've used with, now we're talking to the copy that we create, and we can do some stuff to that copy. So let's think through what we want to have happen on our dead enemy object when it gets created. The way this is going to look visually, again, is that the player will fire bullets at an enemy. When the enemy's hit points reach 0, we'll create a copy of the dead enemy object, and that dead enemy object is going to fly up into the air, either left or right, depending on which direction the bullet came. All right? And then it's going to land back down on the platform and then disappear after a few seconds. So we need to figure out and set the dead enemy object's HSP, our own version of the horizontal speed, dependent upon whether the bullet was coming from the left or from the right. So how do we detect that? Well, we can do an if and then say other, meaning now we're talking back to the original enemy object. And remember, on the original enemy object, we set an instance variable called hit from. And hit from is either going to be 0 or 180. So if hit from is 0, that means the bullet was coming from the left toward the right. So we want this dead enemy object to move to the right. So if it's 0, then let's set the dead enemy's horizontal speed to a positive number, maybe 3. I don't need this here. All right, so else, the only other option for hit from in this game is 180, which means it's coming from the right to the left, so we need our horizontal speed to be a negative number, so I'll just set it to -3. That works. We also want our dead enemy to go flying up in the air. Now, if I go back to our dead enemy, we set up vertical speed already on the dead enemy object, as well as gravity. So we may not actually need to do anything here in terms of setting up the vertical speed on the enemy. Let's try it out and take a look. But we do need to do some other things. We want to make sure here that we show the dead enemy object facing the right direction, just like we've done a zillion times before. So let's do that as well. So we can say if the sign of our horizontal speed that we just set is not equal to 0, remember, so we're moving, then our image x scale, it should seem familiar by now, equals the sign of our horizontal speed. So it's either going to be 1 if it's facing right or -1 if it's facing left, times, we want to make sure that if we've created a big version of our regular enemy object, that the version of the dead enemy object that goes with that, it matches its size. So we need to say other dot size because we set a size variable on our original enemy object. That's the other here. And similarly, we need to set the Y scale of the dead enemy object also equal to the regular enemy object's other size. Okay? That's a whole bunch of stuff going on in there, but that will allow us to do all the stuff we need to do, I think. We'll double check this in a second. And then once we've done all of that, we've now created our dead enemy. The last thing we should do is destroy the regular enemy object. Okay. Well, not inside this with. Now we're back talking to our regular old enemy and just saying, all right, once you've set all this stuff up, get rid of yourself. All right, so we can check to see if this is actually working or not. Hit play, and let's take a look. All right, here we are. We've got our enemies cruising along. Let's come over so I'm on the right-hand side of this guy. Fire away at him, and you'll see he flies up in the air and then drops off to the left-hand side and then disappears after a few seconds. These guys, I'm hitting him from the left, so I've run out of ammo. Right? So that guy gets knocked out and then eventually disappears. So sweet, everything is working just as we like. Well, at this point, we're nearly done with the basic functionality for our enemy. Let me show you a couple more things you can do just to improve things visually on the one hand and also functionally on the other hand. Let's start with the visual piece. So what I'd like to have happen is when I produce one of the dead enemy objects, I want to create a visual effect. We've used visual effects before, and up to now we've used built-in particle effects that are inside GameMaker, and they work just great. For this, I want to just quickly show you how to create your own custom version of a kind of particle effect. So let's create a particle, first of all. What we're going to do is we'll create a little tiny, a little tiny blood sprite. I haven't given you this one in the resources because it's pretty easy to create. So let's just quickly do this in here. So I'm going to create a new sprite. I'm going to call it S blood. Give you a little more practice in creating a blood sprite. In fact, I'm not even going to show it in the video, but I'll show you the end result. What I want you to do is to create a 4-frame image, each with a little simple image of a blot of blood that's a slightly different size. So let's set the size. We'll do at least that. So let's make our canvas be 8 pixels by 8 pixels. And let's set the origin to be middle center, create 4 different frames, and then draw out in each frame a sprite. All right, here's mine. You make yours look however you like. The idea is just you start big and then it gets a little bit smaller frame by frame. That's all there is to it. Okay? This isn't going to actually animate. We're going to just select between these images, so you could make yours look however you like. But the idea is you're creating individual particles of blood. So do that, making sure that you've set the origin to be middle center. Then let's create an object for this called O blood, and give it our S blood sprite. Have a create event for it. And what are we going to set up as variables for each particle of blood? It's going to have an image speed. We don't want this. Well, actually, we can have each particle of blood that we're going to create animate. What we'd like to do is have it animate each particle we're going to have animate at a different possible speed. Okay, So before, when we've said we don't want things to animate, we set image speed equal to 0. And when we wanted them to animate at full speed, we set image speed equal to 1. But what if we want each copy of this blood object to animate at a different speed? Oh, we're going way back to an earlier set of lessons. Do you remember this? We had random range, or I think we used irandom range, which gives us a range of integers between a minimum and a maximum value. Random range works the same way. It's just you don't have integers. You might have a range between 0 and 1 that has like 0.1, 0.2, 0.3, and so on. Okay? So for our range, let's set the minimum equal to 0.05. So real slow. And we'll set the maximum to 0.2, which is still pretty slow. One more little parentheses at the end. So that will be our image speed. Then what? Well, let's set our speed. Now we're using the built-in speed variable. And let's do something similar. Okay, this is the actual speed at which each blood object is going to move around on the screen. And here we want to do random range again, because we want each one of them to move at a different speed, potentially, from other ones. But we'll give it a confined range. It's either going to be 2, 3, or 4. And then we'll set direction. Which direction do we want each one to move? Well, we want it to move in basically any direction, and so to set that up, we can say random 360. So it's going to go anywhere between 0 and 360 degrees for its direction. And we're going to use for this one the built-in version of gravity instead of our own custom version. We'll set it to 0.4. Right. So the idea is that each one of these particles, when it gets created, is going to animate at a sort of random speed between these two values. It's going to move at a random speed between these two values. Its direction is going to be anywhere in a circle. And then we'll apply the built-in gravity to it, so it's going to pull it down toward the ground. Okay? That's what happens on the create. Then we want our blood objects, each copy, to react if it collides with one of our wall objects. So let's set up a collision between the blood object and the wall. And what do we want to have happen if it bounces against a wall? Boy, we are going way back. Well, we can use the built-in bounce function, which we used way back in, gosh, did we use it in fruit? We might have used it back in fruit even. All right, and we're going to say it's going to bounce against anything. Anything, if it runs into the wall, it's going to bounce. Right. And false means we're not going to try to use precise collision detection. We don't need that. Just slow things down. And when it runs into the wall, we also want to apply friction to it. We want to make sure that if the blood hits the floor or the wall and it's moving, then we want to slow it down. Okay? So if its speed is greater than 1, then we will reduce its speed by 1. Okay? When it collides with the wall. And one last thing is that we have multiple frames in our sprite, and so that's a good opportunity to use the animation end event to destroy each copy of our blood. Right. So when we'll play through the animation at a specific speed that we set using image speed, and then when we reach the end of the animation, we'll destroy the copy of the of the blood. Burn my mouse there. Let's do instance destroy. All right, so that sets up everything we need to have happen with each copy of our blood object. That's a lot. So how do we go about creating the blood objects and create a bunch of them? Right? We don't want just one, we want a collection of them. Well, let's go back to our dead enemy object and go back to its create event. And in its create event, let's produce some blood. Okay. All right, here's what we're going to do. We want to create a series of little blood particles. And we don't want it to be the exact same number of blood particles for every dead enemy that gets produced. Visually, it'd be interesting if sometimes we have more blood particles, sometimes we have fewer blood particles. So yet again, we can turn to random range, which we've used before, to choose between how, a minimum number of blood particles and a maximum number of blood particles that we want to create. And in addition to that, this is a little confusing, we want to create a certain number of blood particles, and then we want to position those blood particles sort of around the dead enemy object, right? We don't want them all to appear right in the same location. That would look a little weird. We want to sort of have them move off or appear sort of slightly to the left, slightly to the right, slightly above, slightly below, and so on. So here's what we're going to do. We're going to use a repeat loop. And because we want to create varying numbers of particles for each dead player object, we will use random range and pass it some minimum value, which I'll say is 7, a maximum value I'll say is, or minimum value I say is 4, a maximum I'll say is 7. So for an individual dead player object, this could be 4, 5, 6, or 7. For different copies of the dead enemy object, it could be a different number within that range. So each one could have a different number of these particles. Then what do we want to do? Well, let's set a local variable. And this is going to produce for us the x coordinate. So I'm creating a local variable that I'm calling rand_x. For basically the idea will be a random x position. And I'll set it equal again to our favorite random range. And let's set the x coordinate we'll use anywhere from -4 to 4. Okay. Let's copy this, paste it in, and we'll make one called rand_y, and we'll do the same thing. Then how do we make use of these local custom variables? How do we connect them to the actual position for each of our little blood particles? Well, we can use instance create layer, as we've always done, and we'll take the current x position of the dead player object plus rand_x for the x position. For the y, we'll say the current y position of the dead player object plus rand_y. We need to say, where do we want to produce this thing? I'm trying to remember. I don't think I have a new layer for this, so we'll just put it on the enemy layer, enemy. And what is it we're creating? We're creating one of those blood objects. And that is it. All right, so a random number of times we're going to produce copies of blood objects. Each copy will have its own x and y value that's within this range, and then we'll produce a copy of it using that information. As long as we're here, let's play a sound as well. And we have a sound in here called kill. 10, and we don't want it to loop. All right. So for each one of those particles, we're going to get this little, it's kind of a quiet sound, a little sound here. All right. Ooh, that's a lot of work. All right, so that will produce our blood. Let's try this out. Ha! There's an error. All right. We made an error in our blood object on the create event. You see here I've got image speed and then I've got these parentheses. That's not what we want, right? When we use image speed, image speed is a built-in property, so we need to say image speed equals random range, and then we pass in the values that we want. Okay? So make that correction and then give it a try again. All right, here's our guy. Let's fire at the bad guy. And you see, ooh, nifty. We get these little specks of blood that appear. Oh, I've run out of bullets before I can kill the guy. All right. But you see, it works. So it creates a collection of them. It positions them around the dead enemy object. They sort of look as if they're bouncing around a little bit, and then they disappear. Cool. Well, our lesson's getting a little long, but there is one last thing I want to show you. When we run the game right now, our enemies are able to sort of drop down off a ledge onto a lower ledge, which is the functionality we want. But there may be times in your project where you want to place an enemy on a platform and you don't want to allow them to drop off of that platform. Instead, you want them to patrol back and forth on the platform. So let's do this real quick in here. So I'm going to create a new object and I'm going to call it, let's call it O enemy barrier. This is going to be an invisible object that just stops the enemy from dropping down to a lower level. So I'll use the wall sprite. This isn't going to have any events or actions associated with it on the barrier itself, but it is going to be solid and it's not going to be visible. Okay, got that? Solid, but not visible. Okay. Once you have that set up, if you go back to your enemy object, let's set up a collision between the enemy and this enemy barrier. And what do we want to have happen if the enemy runs into the enemy barrier? We're just going to take whatever its current horizontal speed and set it equal to negative horizontal speed, which has the effect of reversing the direction of the enemy object. With all of that, we'll come back out into our room. And let me give an example. Let's say I want to place one of these guys here, and I don't want them to be able to fall down off of this ledge. Well, let's select our walls layer, grab one of these enemy barriers, place it right on the end there. Then I'll take, I think this is our giant guy, so I'll leave him there. I'm going to take, come to the enemy layer, I'm going to take one of these guys and move him down into this spot. And we'll hit play. All right, now you can see when the big guy hits the edge, he flips around and comes back, and this poor little guy has lost his mind in the corner here. So it's because he's placed down into the floor. So let's drag him up a little because we made him bigger, right? So if you have that kind of weird visual effect on one of your enemies that you have resized, you just want to make sure that you when they get resized, that they're not stuck in the floor. So now our big enemy, when he reaches this edge, he stops. But our player doesn't have anything set up on the player to interact with that object, so he'll just walk right through it. Okay, that's it. We've got pretty much everything we need set up now for our enemies. All right.